Welcome to Italian Innovators, benvenuti. This is Luca Cottini, Associate Professor of Italian Studies at Villanova University. Today, I'm in the company of Fiorenzo Omenetto, French Double Professor of Engineering and a Professor of Biomedical Engineering at Tufts University, where he also holds appointments in the departments of Physics and Electrical Engineering, where he leads the Laboratory for Ultrafast Nonlinear Optics and Biophotonics and serves as Dean of Research for the School of Engineering. His research interests are at the interface of technology, biologically inspired materials, and the natural sciences, with an emphasis on new transformative approaches for sustainable materials for high technology applications. He has proposed and pioneered the use of silk as a material platform for advanced technology with uses in photonics, optoelectronics, and nanotechnology applications. He's co-inventor on several disclosures, more than 100 on the subject, and is actively investigating applications of this technology base, both for technical and design applications. Professor Omenetto was formerly a J. Robert Oppenheimer Fellow at Los Alamos National Laboratories, a Guggenheim Fellow, and a Tauber Foundation Global Leader. He is a Fellow of the Optical Society of America and of the American Physical Society, and a senior member of SPIE. He was named one of the 50 top people in tech by Fortune magazine in a class including, among others, Steve Jobs, Jeff Bezos, Larry Page, and Shigeru Miyamoto. His research has been featured extensively in the press with coverage in the most important media outlets worldwide. And I really invite you to watch on YouTube his TED Talk entitled Silk, the Ancient Material of the Future, to get a glimpse of his work. Now, welcome, Dr. Omenetto, and thank you for being with us today. It's an honor to have you on the show.
Thank you, Luca. A pleasure to be here. That was a lot. I hope I can live up to the expectations of such a long introduction. So
fantastic. So today we'll talk about silk as both a cultural object and a platform of innovation. We'll observe this material from the combined perspective of science and the humanities, and we'll consider the Italian contribution to global research on nanotechnologies. First of all, I want to start from your story. How did you end up in the United States? What led you to work in biomedical engineering, and how did your Italian formation impact your work?
Well, so I don't think that my path is necessarily, linear or thought out or planned at all. So I knew that I wanted to come to the States to do my doctoral research, and so I was schooled at the University of Pavia for my PhD, and my PhD was really in applied physics. I used to work on lasers, and then I came to the States to work on, particularly in a physics department, to work on laser systems. I went to Chicago, and I did my PhD there. So after doing my PhD, my PhD is from the University of Pavia, but after doing my PhD in Chicago, then there was the option to either go back to Italy or just continue the academic path in the United States, which I did, going to Los Alamos, still working on material science while I was there, and working on fiber optics and lasers and lights and stuff and related things. And then at a certain point, I think the calling of university came back, and there was a job opportunity at Tufts, which then turned into an opportunity hire, not in a department that I was traditionally suited to, but it was the Dean of Engineering's suggestion to join the Biomedical Engineering department. And I had absolutely no cross-section with biomedical engineering ever. And so, but it felt good for some reason. It seemed like there were a lot of people that were doing optics there, and that were using lasers, and that were doing optical diagnostics. And so it did make some sense to try to apply things to help, to help people, and to try to help diagnostics and so forth. And this is where I joined and I started my lab, and this is with a conversation in the hallway I started working on silk because of David Kaplan, who was and still is the head of the department, and he showed me a piece of silk, and that kind of led to everything else. And so yeah, I came to the States to do my PhD, and I ended up staying. Like, and I think that this is sort of like the story of many people.
It's quite a familiar story.
Yes, and so and then I got sort of like derailed along this path, pleasantly derailed along this path, and ended up joining a biomedical engineering department.
But
So
this
it
is
was
luckily the path of research as a non-circular
that's
endeavor,
right.
really a ramification.
That's absolutely right. So here I am now. I've been in Boston for 15 years now, and working a lot with worm spit. So there you have it. Yeah.
So silk, which is a fascinating material in between technology and culture, it's a natural component known since the ancient time, which contains an immense potential for future developments, as we'll discuss. Now, historically, silk has been a trademark of Italian style, as well as one of Italy's earliest industries, especially in the area of Como and Varese, where we're both from. Why did silk culture develop in Italy there? And in your opinion, what made it so successful in terms of quality of the product and market reach?
Well, I think I think historically there were Italy being a country on important trade routes in the Mediterranean. It was sort of a I wouldn't say a foregone conclusion, but it was an inevitable almost event that eventually through the Silk Road, through China, and weaving its way through a westward path, that silk would eventually make it to our peninsula. And it's very popularized. It's very popular to think that Marco Polo was the main distributor of and it, to a certain extent, it's true, although before Marco Polo, a lot of silk appeared around the 800s in southern Italy and in places like Calabria and Campania. And so there were first documented things about the fabric being documented, and fabrics use being documented in these places. So you fast forward many years, and then there was the textile industry and the favorable climate and the type of cultures that that both require the mulberries and the post-processing and the cleaning of the fibers, etc., just took hold in northern Italy prevalently. And it was the northern Italian area along with almost southern France and the Lyon region where some of these things became very, very prevalent, in Veneto and Lombardy and so forth. Bologna was also a very important silk city.
It was really a trade of excellence, Italian excellence. So now, moving to your research, why did you get interested in silk? Partly you responded earlier with your experience, but can you tell us something about its applications to modern living and what you're researching about?
Sure. I mean, so David, that I mentioned beforehand, so my colleague, has worked on silk for a long time. And so basically the concept is that you take the fiber and you break it down into its initial components, its protein components that are, if you will, the building blocks that allow to construct material. So if you take the fiber and you extract the bricks that make it, then and you're good at reassembling the bricks, you can build different things. And David specifically, because of the benign nature of silk, the fact that it's implantable, the fact that it's non-inflammatory, et cetera, was using it as a scaffold for tissue engineering applications. So we had a conversation in the hallway, really, and he showed me like this little piece of transparent material and said that this was going to be a replacement cornea. And the idea was to have this scaffold and have stem cells, grow into that scaffold and recreate a living cornea that could be used for transplantation. That's the general concept of tissue engineering, is to give a form, a shape, a mechanical, a mechanical environment so that cells recognize sort of the mechanical cues and the three-dimensional cues and rebuild and differentiate into something that then you want to build. So he showed me this and asked whether with our lasers we could put some holes inside this transparent film so that the cells could go in and start growing. And we tried to do that. I remember putting a laser beam on it and not seeing the laser beam, which to an optics person means that the surface of the material is incredibly smooth. It means that it's a very, very, very high optical quality. And then we started asking questions about whether anybody had used it for advanced optical applications. Then the optics led to electronics, and then all of these crossover applications came about functional materials. And that's really how I got started. It was through a chance conversation in the hallway, really, and a bit of connecting the dots is taking something and really that was meant to be implanted in the body and actually thinking about it in a completely different context that is generally the domain of semiconductors and glasses and all these types of things. So I got started by chance without knowing really. I hadn't really done anything at all with silk before that day. I mean, except maybe wear a tie every now and then. But that's how I got started with silk. And then you asked about where does it go? Well, where it leads is that you have a material that can match what glass and silicon and other technical devices can do, except that it's a material that stays biologically active, that preserves biological materials, that can melt on command, that you can eat, that you can implant. And so suddenly all your technologies become applicable in places that you really didn't think about before. And so this enables a lot of really interesting crossover applications that go back to medicine, but that also go to sustainability, to food preservation, to to Internet of food versus Internet of tissues, to very weird implants and all these types of things.
So really, silk is a piazza where multiple disciplines come together, and this is really a fascinating work of scientist and engineer, but also of a humanist.
It really is. And, I mean, I don't want to jump the gun here, but we were fortunate enough to build a very nice for lack of a better term, I don't like the word interdisciplinary, but it is a very, a very anti-disciplinary space where we have basically all people from the sciences and from different branches of engineering that coexist with artists in residence, architects, Olympians, musicians, and they sort of come together with this very rich dialogue on defining meaningful questions and trying to figure out what really could have impact and what could define some things that are unexpected. So there is a bit of a humanist approach in all of this, I would say as well.
Well, certainly your work at Silk is a paradigm of innovative thinking, and not of innovation as a random pursuit of novelties, but rather as the creative observation of the real, as the ability to see value inside the flat surface of matter and find a resource in what is in nature. In the same way, for example, Carl Joseph Bayer developed a technique to extract aluminum from bauxite, which was an ore that made soil infertile in 1887, or the London doctor Alexander Fleming saw in the pest of penicillin mold an ideal bacterial killer in the 1920s. So how does innovation work? Where does it start in experience, and what is innovation for you?
That's a very easy question you're asking, Luca.
Yes.
and I, of course, I don't know. I mean, I think that the answer is going to sound trite, but innovation starts from curiosity and the capacity to connect. You have to be sort of always be able to look with some degree of wonder outside of your field, and try to really see where commonalities appear. And it's very it's you know the ability to continue to connect and to connect with people and to communicate with like people, I think leads to some of innovation, for lack of a better description. It leads to broadening the horizons and getting unexpected results. It's more about people willing to risk, people willing to recognize similarities in their language, and people willing to translate one domain into the other. I really think that some of innovation comes from observation and play, and with a dose of pragmatism, right? Then you need to translate it into something that you can touch, you can see, you might, and this is, for applied sciences, of course. If you're innovating in something that is more abstract, or in a theory, then it's still a similar connecting exercise, but it doesn't translate into an object. It translates into something that is a little bit more that is less tangible, if you will, from a material standpoint. But
so in a way, the dialogue that by indirect means might open up comparison and a space of connection, but also play. And play is very important also for designers. It's a capacity of imagination and connection of previously compartmentalized disciplines or areas that in their reaction might lead to something else, something new.
And in fact, I think that it is a people first approach, because I believe that people that have a certain sense of aesthetics and a certain sense of aesthetics of the question, and want to and have a capacity to distill the problem and sort of try to find elegant solutions. And this, I understand that this is a very vague definition, but you have people that really dissect the problems and try to get to a point that is very and try to find meaningful results in their work. Then it doesn't really matter what discipline they pertain to. I think that there are common metrics that these people have in order to come to that question. And so you can put them together in a room, and you will have, and they will get famously along, because they do share the same standards of investigation and of thought process and of rigor, that then allows them to communicate. And then the communication is really between some topics that ordinarily don't belong together. And so that becomes very exciting, because an excitement shared then becomes immediately an excitement that grows in a certain sense.
Definitely. So silk is a privileged material for an engineer like you, but also for designers, as we said, especially fashion designers.
Sure.
Now, in a previous episode of the show on the costume designer, Milena Canonero, winner of 4 Academy Awards for costume design, we recall the opening pages of Collodi's The Adventures of Pinocchio, where placed in front of the same piece of wood, the carpenter, Maestro Ciliegia, refuses to go beyond its surface. And Geppetto sees in it instead a puppet that can dance and sing and fence. And it seems like your work, in a way, requires, the same degree of creativity and imagination. You talked a little bit about it, but what is the role of imagination in engineering? And how does your gaze on matter reflects or differs from that of an artist?
Well, so first of all, it's a very flattering comparison to be in the same conversation as Geppetto. This is very, I think that this is the best compliment that anybody has ever bestowed on me. So I think, you do, especially this fits, the example of Pinocchio maybe is particularly fitting to silk, because there is hidden life in the materials that you make through the inclusion of biology in these forms that otherwise would be inert. there are things that you can do where the materials come alive and they really respond to the environment around them, and they contain certain biological features and biological responses that are quite quite unusual when compared to the traditional materials of engineering. And so that immediately makes you dream about, what would you do if you could eat, what would you do if you could eat a phone? What would you do if you could implant the screen of your phone? And so, immediately you do have to kind of think creatively, because these are pushing a little bit the limits of what material science certainly can do. And I think imagination always, imagination always plays a role, because imagination um, tends to do leaps between, it tends to be a nonlinear connection, and it tends to try to reach for the unexpected. And where the science comes in is to try to see whether you could be pragmatic about very imaginative things. And I think that the exercise between trying to go towards something that has never been done before, and then bring it back to, to your methods, and trying to be creative on how to connect the methods to these wild ideas becomes, becomes your part and parcel of your daily exercises, and so it's very interesting, because we have this program that we do often with Berklee College of Music, and we have musicians that come to the lab and speak about the way that they think when they improvise, and when they think about composing a musical tune, versus the way that we think about a new format of silk. And if you think about it, it's a very simple analogy. A musician in the Western world has 12 tones in a scale, and they evoke emotion. And we have one protein, and we make a lot of things. And then you take them and you ask them to discuss this issue, and the conversations are fantastic. And you really do see sort of like the same approach to problems: is what is unexpected? How do you do this? How do you match your technique when you play to the emotion that you generate? How do you match the science that you know, and the methods that you know, to a result that is unexpected because of the materials that you use? And suddenly these are the types of things that really build the creativity, and actually make it a lot of fun to work in these contexts. So
Definitely, sort of like imagination postulates a horizon, science walks the way.
That's right. That's absolutely right. And so science is the reduction to practice of the flights of your mind, right? And so if your science allows you to jump between things and connect things, then it's likely that you might be able to dream wild things to invent. And
Mhm.
so
Definitely. Also, in many cases, literary imagination really preceded geographic or scientific discoveries. So Columbus was allegedly inspired by Dante's account of Ulysses passing the Pillar of Hercules in the Divine Comedy. And science fiction, of course, anticipated human journeys to the moon and many medical discoveries. So what are the books or films that impacted your research the most?
um so well, I would say that as far as books, I can cite two. I think that The Little Prince and generally Antoine de Saint-Exupéry has always had this sort of like adventurer spirit, looking beyond the form, the shape, the meaning, besides being a spectacular book per se. But there was always the sense of trying to venture into the unknown, and trying to be daring about these things with genuinely, a childish, kind of like the curiosity of a child. And I think that this was always something that stuck with me. when I when we transition from one phase to the next of our academic life here at Tufts, the library at Tufts buys we tell them what is a meaningful book to us, and they buy it and they put it in the library with our name as a symbol of transition. The book I think that I chose was the complete works of Calvin and Hobbes, the comic strip, because besides the fact that I think that Bill Watterson is a genius, a very kind of like a very and an innovator in its own way in terms of breaking from the syndicate restrictions on panels for daily comics and so forth, and being a very sensible and sensitive soul. There is an aspect of this relationship between Calvin and his tiger that really gives life to the lifeless, and goes into endless avenues of imagination, creativity, interaction, affection, and ranges of emotions that that sort of take kind of represent everything that curiosity, imagination, and sort of like wonder should be. And so those are the two books.
Oh, thank you. No, and I understand that I'm taking you outside of your comfort zone. I'm taking you to kind of a more humanistic approach, but I also want to go back to your research in biomedical engineering, and also wanted to ask as a last question, what are, in your opinion, the projects, the most notable projects that Italy is currently leading in the sector, and what you think is the Italian contribution to global research on kind of nanostructured materials?
Well, I mean, as far as nanostructured materials, Italy has always been an incredible country for innovation and technology. I think in my laboratory, there's always a very large contingent of Italian researchers, and they always do extremely well. They are the way that they're formed, their creative spirit is always second to none. I think as far as the projects in Italy, there are many, and there are many groups that are doing very excellent things in these types of arenas. I think of many places in Milan, the Polytechnic of Milan, the IIT, so IIT in Genova. But so, I mean, I can tell you who we work with. I mean, we work with Milan, we work with Pavia, we work with Bari. They're all wonderful colleagues all across the board. It's very hard to pinpoint, where who is the best, and do a ranking of who is the best. I think that there's an overall always high quality of work that is always sort of undermined by sometimes a little bit of a clunky and a bit inefficient system. I'm talking to an Italian that is abroad, from an Italian that is abroad. There's just an execution speed sometimes in the system that may hold the development times a little bit back. But I think it also helps creativity somewhat, because it forces you to think about ways to be efficient that are unconventional, and I think that our transition from academia to advanced tertiary, so to small business, is second to none. And in fact, I would argue that it's probably one of the leading industrial development areas in the world.
Yeah, certainly. Also, the limit or the lack of resources is a great stimulus to creativity, to the urgency of finding alternative solutions.
No, absolutely, and there are these things that are almost immobile that are immobilized in process, and there are things like very slow uptakes and slow deliveries, and sort of like systems and infrastructure that sometimes does not match the utter brain power that exists in these types of things. So yeah, I mean, it's Italy is a great place. I mean, it's if appropriately managed, I think that research in Italy would be even more powerful than what it is already, and that's would be absolutely at the top of the crop.
Well, thank you very much for this very enlightening conversation. We talked about Silk as really a platform of imaginative thinking in the industry, the arts, and in biomedical engineering. And we really observe how an ancient material can bear at the same time a long-lasting cultural value and an innovative potential for the future. And we discussed about lastly about the Italian place in this global network of research. So Italy is connected to the global network of research that you're part of, also here in the United States. Thank you very much for the conversation. It was a real pleasure to have you in the show.
You're very welcome. Thank you for having me.
And thank you all for listening. Make sure to visit the official webpage of the show at www.italianinnovators.com for a complete list of episodes and more information about this project. Also, don't forget to check out the YouTube channel and subscribe for more video content and the lessons of the Italian Innovators course. You can also follow me on LinkedIn, Twitter, or Instagram for updates, news, and additional materials. Thank you for your support. Arrivederci e alla prossima.